So hello, sorry for this delay. We had a technical problem, but I think that we are okay now and we can start. Can you hear me? George, can you hear me? Okay. So, ladies and gentlemen, my colleagues, Dr. Sakas, and I, as leaders of the working group infrastructure, would like to extend a warm and a friendly welcome to each and every one of you who have joined us today for this webinar. We are here to delve into the analysis of current trends in integrated wildfire risk management and critical infrastructure dynamics. This webinar has been carefully crafted to provide an in-depth exploration of predicting future challenges and opportunities for resilience in these two key areas. Our esteemed speakers are prepared to share their wealth of knowledge and engage in thought-provoking discussions on these critical topics with the assistance of our esteemed moderators. I would like also to outline some key guidelines for our time together. This includes the recording of today's workshop for future reference and will be made available after editing to ensure that our insights can reach a wider audience through YouTube. So if any of the moderators or the presenters prefer not to be recorded, please feel free to turn off your camera during the session. Now, on the other side, about the audience now, your active participation through the chat and Q&A features is highly encouraged, as we aim for an engaging and interactive discussion during and at the end of the four presentations. Your insights and questions will undoubtedly enrich our exploration of wildfire risk management and critical infrastructure dynamics. And now, please allow me to give you a very brief overview of the objective of the Infrastructure Working Group. The Infrastructure Working Group aims to thoroughly investigate the intricate relationship between fire and infrastructure. Initial focus includes understanding how infrastructure shapes the fire regime, examining the potential consequences of infrastructure malfunctions on fire initiation and emphasizing the pivotal role of risk assessment in landscape planning and disaster management. Furthermore, the group seeks to analyze the impact of wildfires on infrastructure and vice versa. Emphasis is placed on the necessity of comprehensive planning, ongoing training, and robust protection measures for infrastructure operators, along with enhancing landscape resilience to mitigate these disruptions. And these critical aspects will drive our today's discussions and generate innovative ideas during the webinar. Our group has already participated in two workshops, one in Solsona, Spain, and one in Macri, Athens. And through today's webinar, the primary objective is to develop a policy recommendation document addressing the complexities of wildfire risk management, aiming to deepen comprehension and advocate for proactive strategies in this specialized domain. Your presence, of course, here today adds immeasurable value to this webinar, and myself and my colleagues, Dr. Sakas, are truly delighted to have you all with us as we embark on this journey of exploration and knowledge sharing in the field of wildfire risk management and critical infrastructure dynamics. So, welcome everyone, and let us together embrace the highlighting experience that lies ahead. Now, I would like to give the floor to Dr. Sebastian Wagner to provide us a brief overview of the Firelogue project and a friendly welcome. Dr. Wagner, your floor is yours. The floor is yours, excuse me.
Thank you, Nikos. Thank you very much for having me. Thanks for joining. 95 people, that's a lot. So thank you for taking the time for us. So thank you for having me. First of all, I would like to briefly introduce you to the Firelogue project. The Firelogue project was funded under the European Green Deal, and it's a coordinating and support action that leads the way in addressing the critical issue of wildfires by integrating insights from different innovation actions, 3 innovation actions, and a precursor project, and various stakeholder groups. Our mission is to develop and share comprehensive strategies that reduce wildfire risks, taking into account systemic risks and employing cross-sectoral approaches. And for that, we have created a platform that's called Lessons on Fire, one word, .firelogue.eu, and that does exactly that. So this is the sharing component, and Firelogue, the project, facilitates collaboration in working groups, bringing together experts from diverse fields such as environment, civil protection, insurance, societal, and, as you see today, infrastructure resilience. We organize clustering events, thematic workshops that were mentioned before, and webinars as the one today. Our emphasis is on public participation, transparency, and fairness, and this ensures that wildfire risk management is not only effective, but also inclusive. And this helps us, as with the topic today, when we want to promote the creation of robust and resilient infrastructure systems that can withstand the devastating effects of forest fires, for instance. A key component of the Firelogue project is its connection to critical infrastructure dynamics. Through our infrastructure working group that hosts this webinar today, we adopt a comprehensive approach to understanding and mitigating the interactions between infrastructure and wildfires. By preventing fire ignitions caused by infrastructure malfunctions, for instance, and ensuring that critical infrastructure can recover swiftly from wildfire impacts, we aim to maintain essential services and minimize socioeconomic disruptions. Our vision is to create a collaborative cross-sector dialogue that brings together stakeholders from various disciplines, and they are, luckily, we have lots of them here today. And Firelogue, as the name implies, fosters this dialogue, and it aims to develop comprehensive strategies and recommendations for the wildfire risk management community. Our focus is on improving resilience, reducing wildfire ignitions, and minimizing both socioeconomic and environmental impacts. Firelogue seeks thus to build a proactive and well-informed community through the sharing of best practices, of lessons learned, and the creation of policy recommendations. We are committed to more effective prevention and management of forest fires, and in doing so, protecting vital infrastructure. So this is it for Firelogue. Thank you very much.
Thank you very much, Dr. Wagner. And before I hand over to my colleague, Dr. Sakas, to introduce the moderators for today's webinar, I forgot to introduce myself. Sorry for that. So I'm Nikolaos Kalapodis. I'm a senior researcher in the Center for Security Studies from Hellenic Ministry of Citizen Protection, and I'm a forest management expert. So, Dr. Sakas, please, the floor is yours.
Thank you, Nikos. First of all, apologies again for the delay. We probably have solved all the technical problems. I'm a colleague of Nikos. I work also in the Center for Security Studies in Greece. I'm a disaster management expert. And now we shouldn't, let's say, waste more time. I would like to introduce to you our moderators. We have two moderators today, Mr. Alex Marangidis and Dr. Dionysios Kolaitis. Mr. Marangidis holds the BAc is a mechanical engineering from with, let's say, focus on aerospace concentration and a master's degree in the fire protection and engineering from the Worcester Polytechnic Institute in the USA. He has, let's say, a remarkable 30 years of experience in large-scale testing and 20 years in post-fire reconstruction. So Mr. Maragidis is, let's say, one of our true experts in the field. During his tenure, Mr. Maragidis at the United States Naval Research Laboratory played a vital role in the Navy's Hellenic replacement program and served as the test director of this program. From his transition from the Naval Research Laboratory to the National Institute of Science and Technology of the USA, the NIST, he led the Large Fire Laboratory, overseeing the execution of numerous large-scale experiments. For the past 2 decades, Mr. Maragidis has dedicated his research to the National Wildland Urban Interface problem on fires, the usual Wildfires, leading all the 4 NIST Wildfire reconstructions. His findings have significantly influenced national and regional codes, standards, and best practice in the field. Currently, Mr. Maragidis is at the forefront of the NIST investigation of the California Camp Fire and the Structure Separation Experiments Cross-Agency Research Project. As a lead author of the recently released Hazard Mitigation Methodology and Evacuation and Sheltering Considerations Methodology, he continues to provide invaluable technical input to multiple federal and state agencies and other non-governmental organizations. With his extensive knowledge and leadership in fire sciences and technology implementation, Mr. Maragidis is a pivotal figure in advancing research and practices in the USA and overseas. We are truly privileged to have him here as one of our moderators for the discussion that is going to be held today. As regards to our second moderator, Dr. Kolaitis, he is an assistant professor at the School of Mechanical Engineering at the National Technical University of Athens here in Greece. He holds a diploma in mechanical engineering and a PhD from the same institution from 2005. His focus is on fire initiation, fire spreading, and suppression in various environments, and his expertise extends to fire behavior of construction products, innovative combustion technologies, and energy efficiency in buildings. With over 100 publications in international scientific journals and conferences, Dr. Kolaitis is a prolific researcher who has contributed to more than 30 research projects. He plays a pivotal role in teaching undergraduate and postgraduate courses at the School of Mechanical Engineering, covering areas such as fire engineering, combustion, transport phenomena, numerical simulations, and building energy systems. As the technical manager of the National Technical University of Athens in Fire Engineering Unit, Dr. Kolaitis leads the only accredited and notified laboratory in Greece conducting reaction to fire tests according to the European standard 13501/1. Since 2017, he has served as the national representative for Greece in various technical committees of the ISO and the CEN organization concerning fire engineering. Dr. Kolaitis' profound expertise and dedication to advancing fire engineering make him a valuable asset as one of our moderators today. So now I would like to give the floor to Mr. Maragidis to present us, to make us a short introduction of our speakers today, so that then we can proceed with the presentation. Alex, the floor is yours. Okay, we're having a new technical problem. This is interesting. We'll figure it out. Alex, I think that you can, yeah.
Hello, everyone. Great. Thank you for having me. Great to be here with over 100 attendees from around the world. It's a privilege, and thank you for giving me the opportunity to be a moderator in this very exciting couple of hours coming up. So I'm going to take the opportunity here to introduce our esteemed speakers. And then I'm going to turn over to Dionysios, who's going to manage the event during the presentations. So first, we're going to hear from Dr. Emilia Gugliandolo. Emilia graduated as doctor with laude in management engineering from the University of Salento in Italy. And she's currently working as project manager in the data and analytics R&I lab at Engineering Ingegneria Informatica S.p.A. As part of Decision Support Systems unit. Emilia deals with security, intelligence systems, and Internet of Things, big data analytics, business intelligence, and social business. Since 2015, Emilia has focused her expertise in the disaster resilience and critical infrastructure protection domains, being involved in numerous H2020 and Horizon Europe projects, dealing with security, critical infrastructure protection, and disaster resilience. She's the EU-CIP project coordinator, and Emilia has specialized in the roles of innovation and exploitation manager. After Emilia, we're going to hear from Dr. Miltiadis Athanasiou. Miltiadis holds a PhD in Wildland Fire Science from the National and Kapodistrian University in Athens, and has been a volunteer firefighter for 25 years. He has worked in aerial firefighting as crew member of heavy lift helicopters in Greece for the last 5 seasons. Miltiadis's work includes documentation of wildland fire behavior in the field, specifically in context of analysis, fuel modeling, fire risk assessment and prediction, and past firefighting accident reconstructions, case studies. Miltiadis trains firefighters on wildfire behavior, hazards, firefighting tactics, human factors, safety, and health on the fire line. Also, he tries to promote the use of fire in fire prevention in Greece, which at the time is not legally recognized. This is an emerging field for the country. After that, we're going to hear a combined presentation from Anthony Schultz and Mike Cox. Anthony is the director of Wildland Fire Solutions at Esri. His background in wildland fire management and operations began as a wildland firefighter and progressed to responsibility for planning, program direction, and coordination of Wyoming's Wildland Fire Program as the state's Fire Management Officer, FMO. During his tenure as the state's FMO, he chaired the Western State Fire Managers and was a Rocky Mountain Coordinating Group member. These are significant activities in the US. He also served as a FMO, Fire Manager Officer, with the state of North Dakota. As a wildland firefighter, he has worked for several federal agencies, including the Bureau of Land Management, BLM, and the National Park Service, NPS. In the same presentation, we can also hear from Mike Cox. Mike's the Director of Fire, Rescue, and EMS Solutions for Esri. And Mike's responsibilities include advocating for fire and EMS agencies leveraging geospatial information and technology to achieve their response and recovery goals. Mike is retired from Henrico County in Virginia, where he was at the fire department for 27 years. He served as deputy chief with responsibilities including operations, emergency management, planning, accreditation, budget, and human resources. He's also a member of the Central Virginia All Hazard Incident Management Team and was technical rescue team leader. Mike has also served as a hazmat specialist in the Virginia Department of Emergency Management Regional Hazardous Materials Team. The last presentation today is going to be by Dr. Monica Cardarilli. Monica is an advanced science for policy researcher at the European Commission Joint Research Center. She provides scientific advice to EU policymakers in the area of security, defense, critical infrastructure resilience, hybrid threats, and supports Commission services, including member states and other relevant stakeholders. So as you can see, we have a very well-established group of speakers with very impressive credentials. And I look forward to all the presentations and the following discussion. So I'm going to turn it over to Dionysos to get this going. Thank you very much.
Hello, everybody. Thank you, Alex. Thanks also to the host for the kind invitation to this very interesting webinar. Just a few words about the organization of the webinar and the presentations. We have essentially 10 minutes of a presentation for each speaker, and there are 4 to 5 minutes allowed for some questions there and answers. Of course, all participants may write a question in the chat or the Q&A, and in case there are more questions that can be answered at this very short time, these questions are going to be answered later on at the panel discussion. So don't worry, all questions will be answered eventually. So just since we had a bit of a delay, I would like to ask for all speakers to try as much as possible to keep their presentations within the 10 or at maximum 15 minutes limit. So without further ado, I ask Emilia to start her presentation titled Overview of the EU-CIP Project for Resilient Infrastructures. Emilia, the floor is yours.
Good afternoon. Thanks for the presentation and for this opportunity. As presented before, I'm from Engineering Ingegneria Informatica, and I'm the EU-CIP project coordinator. And now I can try to give you a brief overview of the EU-CIP project and how this project can support the relationship among wildfires, infrastructure, and resilience. Just a practical question. Can I share my screen, or you can go ahead with the presentation?
I think the presentation.
Emilia,
yeah.
What if you prefer? You have to. There's a button up that upstairs, not upstairs, to the up part of the screen that says "Take Control." If you want, press this button in order for you to take the control of the presentation and change the slide. Otherwise, we can change the slides, whatever you prefer.
If I can try to find the button, I can.
It's on the upper part next to the chat, a bit left from the chat.
Probably.
Okay, we can change the slides.
I don't know if it's. It's not the correct button, probably.
Okay. I don't know. Something is happening, with Teams, probably with the versions and the emails. Maybe you can proceed and we can change the slides. We do have your presentation, so that it's not a problem for us.
Since I find the button, but that is not active. So I cannot manage.
Emilia,
okay.
If you want, I can stop sharing my screen and you can.
I can share the screen.
Yeah. Okay. Let's do it. Yeah, in this way. Thank you. Thank you.
Thank you. Okay. Let me know if you see the presentation, the screen in presentation mode.
Yes, but we can see the
Now, yes.
Exactly. Yeah.
Okay, perfect.
It's perfect. Yeah. Thank you, Emilia.
Thank you. So, as I said before, I will give you the brief overview on the project and the support for wildfire infrastructure and resilience. The EU-CIP project is a 3-year coordination and support action funded by the European Commission under the call topic SSRI. The EU-CIP project started in October 2022, so will last 3 years until September 2025. The consortium of the EU-CIP has 20 partners, including the coordinators of recent European projects dealing with the resilience infrastructure in different sectors. And these coordinators in this project are part of the EXI cluster. So the project is a natural evolution of the EXI knowledge network on resilience infrastructure. The EU-CIP mission is to offer data analysis and services for the development of evidence-based research and innovation policies and opportunities in the CIP domain. In order to understand the landscape at basis of the EU-CIP, we have to take in mind that innovation and policy development for resilience infrastructure and critical infrastructure protection is a complex, very multidisciplinary process that involves different types of stakeholders, critical infrastructure operators, authorities, innovators, technology providers, and so on, and must analyze a very rich state of data and information from different sources. So the main driver at the basis of the EU-CIP is to reduce information fragmentation, ensure a structured analysis, and boost evidence-based policy making. So the main goal of the EU-CIP is to establish a novel pan-European knowledge network for resilience infrastructure, and that enable policymakers to shape and produce data-driven evidence-based policies, boosting at the same time the innovation capacity for critical infrastructure operators, authorities, and innovators. So the challenges of critical infrastructure related to wildfire are several. At first, we have to consider the vulnerabilities to fire damage, since many critical infrastructure are vulnerable to different type of hazard and also to wildfire damage. And this can lead to service disruption, safety hazard, and different type of threats. We have also to take in mind the interconnectedness among all the infrastructure. That means that wildfire in one infrastructure can have cascading effects on other type of critical infrastructure. Also, the aspect of resource allocation, it's important, since effective wildfire management requires resources and coordination among different and several stakeholders. And the adaptation and resilience is another important aspect, since infrastructure can adapt and recover for wildfire as a continuous challenge in order to provide business continuity. So EU-CIP aims to enhance the resilience of critical infrastructure against various types of risks, including wildfires. So integration of wildfire risk management into critical infrastructure protection in general will ensure a comprehensive approach to resilience, to safety. And moreover, wildfire risk management is very, very crucial for protecting critical infrastructure and communication network for fire damages. And in this context, how EU-CIP can deal with wildfire risk management in different ways, with data analysis and insight. So EU-CIP can collect and analyze data on wildfire incidents and their impact on critical infrastructure, with the policy development, since one of the aims of the EU-CIP is to provide evidence-based guidance for developing policies and standards. The innovation support, since EU-CIP encourages the development of innovative solutions for wildfire detection, prevention, and response, or in general for critical infrastructure protection. and also stakeholder engagements, since involves different type of critical operators, policymakers, innovators in wildfire risk management initiative. In order to understand how the consortium of EU-CIP carry on this work, we have to take in mind that the work is focalized on three main objectives. EU-CIP analysis to enhance European analytical capability regarding research outcome, technologies, policies, foster data-driven evidence-based policy and innovation developments. In this case, EU-CIP has provided a well-structured information collection and analysis infrastructure, and the information to be collected and analyzed is related to security research activities, outcome, past project, main technologies, and so on. The objective number 2, EU-CIP Amplify, aims to maximize the impact of research and innovation CIP-CIR activities in Europe through innovation support and solution validation services. So EU-CIP will offer a set of services to support commercialization and innovation of past solution. And the third objective, EU-CIP ecosystem, aims to establish a knowledge hub and create a vibrant ecosystem of stakeholders around the results of the project. These are main highlights, the results that until now EU-CIP has provided. We have gathered a list of capability needs and gaps, and this list is continuously updated, refinements in order to be improved based on stakeholder feedback. And we also analyze a list of state-of-the-art technologies that support to overcome the capability gaps. We have provided some sectorial white paper, 5 sectorial white papers, and these white papers are available in the Knowledge Hub, but also on Zenodo. Another results is the EU-CIP Virtual Innovation Hub that support innovators to commercialize and to obtain innovation support for their solution and prototype. We also provide business plan and co-creation support services, an innovation lab for solution validation, and a catalog of best practice and success stories. Another highlight is the EU-CIP training and skill development pillar. At the moment, we have provided free EU-CIP courses, free webinar, and a catalog of more than 130 party courses. And the EU-CIP Knowledge Hub that is a unique point of access to the project results, boosting knowledge sharing and collaboration among all the different stakeholders involved in the CIP, CIR. And the main aim is to mitigate information fragmentation. All the topic and all the content of the EU-CIP Knowledge Hub are strictly linked among together. This is the main homepage of the Knowledge Hub. As you can see, is a dynamic web page with the different news, events, and on the left we have the content and the service provided. I will give you a brief overview of the main content provided. For example, the solution section, where you can find a list of previous developed solution in past projects. And you can have a brief overview on each solution, but also to suggest your own solution in order to enhance the visibility and the impact of the solution. Another important section is training courses. As I said before, you can find here a catalog of different courses chosen to fill the skill shortages, but also a section related to EU-CIP courses that has been produced in the project. And you can also suggest courses that has been developed in your own project and will be inserted in third-party courses. Then another section is the innovator content. As I said before, we support and elevate the effort of innovators in supporting exploitation, commercialization, standardization, and certification of research outcomes. So you can find here an innovation support form that can be filled in order to have our support, some training related to commercialization, and also a catalog of best practice and success stories. and also knowledge asset when you can find our sectorial white paper, value-added report, and other relevant knowledge assets. And another section is the thematic group 1, where you can find different topics and you can start discussing and providing feedback among all the stakeholders registered in the Knowledge Hub. So how EU-CIP support wildfire risk management also with the EU-CIP Knowledge Hub, providing a centralized information repository, since it's a single point of access to all the data, research outcomes, so you can find here. And also in the next week, you can also suggest for each of the categories your own resources, so for the Knowledge Hub solution and for knowledge assets. A collaboration platform that facilitates collaboration among all the different stakeholders, as I said before, using thematic groups, but we also provide a collaborative environment with the chat, social profiles, events. You can share your own events in the common calendar in order to promote your events. Training and capacity building, offer training courses and resources. You can have a specific section, and in the next week you can also suggest a course that you need but that is not available on the Knowledge Hub, and the innovation support to support the development and validation of innovative solutions with the Knowledge Hub innovators content section. So EU-CIP can, with the Knowledge Hub, can enhance your visibility and the impact of your project or your solution, your results, give an access to a broader network with a different type of stakeholder. You can also receive feedback and support, but also the policy influence, since we will support the evidence-based policy production. And I give you here the link and also the QR code to register in the Knowledge Hub, since it's important to have a great community. And as I said before, we will improve our Knowledge Hub, and by the next week you can also suggest your own solution, your own resource, in order to have the contribution from all the users in the community. So this is all from my side, and thank you so much.
Thank you, Emilia. Thank you very much for keeping the time. I just wanted to note that if someone has a question to address to a speaker, it's better to write it in the chat box, since the Q&A doesn't work sometimes if you are not participating through the Teams desktop app. So we'll thank Emilia once more for the time being. We'll have some time to answer some questions later on the panel discussion. And I would like to welcome now Miltiadis Athanasiou, who is going to present wildfires and infrastructures, understanding the challenges, managing the risk. I want to remind Miltios that the projected length of each presentation is 10 to 15 minutes. So please, let's try to keep within these boundaries. So Miltios, the floor is yours.
Yeah. Thank you very much for inviting me to be a speaker in this webinar. It gives me a great pleasure. So we'll speak about infrastructure and some challenges we have to face regarding wildfire management. Regarding hard infrastructures, that is roads, railways, electrical grids, telecommunications, we all know that, for example, along electrical grid, across electrical grid, failures cause wildfires. There are many cases of that kind of fires, while on the other hand, let me say, wildfires cause grid failures. So many problems arise from these incidents, and of course it's not only electricity networks but also cellular ones, which are vulnerable to wildfires. There are many other cases during which we experience wildfires starting from along networks such as railroads, and of course cases of fires starting near or on a road. And of course, on the other hand, there are many cases during which either civilians or first responders are being seriously threatened as they find themselves either entrapped or seriously threatened by wildfires during some evacuation efforts or while first responders try to reach the fire area. Anyways, sometimes thick smoke close to coasts or along roads compromise or block the escape and evacuation routes and trap people. We have experienced many times incidents like these, and sometimes the result is tragic, and we have not only injuries but fatalities also. In cases of fast-moving fires, last-minute large-scale evacuation, we are sure we can say that increase the risk of entrapments and burnovers, particularly while and urban interface areas, while spotting potential, that is density or distances, which we may find spot fires, amplify this likelihood and this potential. Many countries around the globe face this exponentially growing problem, that is while and urban interface fires, a very complex problem. We can classify in three general categories, the wild interface areas regarding to their characteristics, and we are trying to somehow minimize, to reduce wildfire hazard by preventing wildfires, by managing the forest fuels, which not only reduces the risk, mitigates the risk, but also contributes in the long term to a climate resilient future with many ways, by maintaining grid belts, creating or maintaining fuel breaks or fire breaks, and utilizing and by utilizing either along electricity networks various combinations of fuel treatment methods such as mechanical treatments, grazing, or prescribed burning. Agroforestry can play an important role in landscape fire prevention. This is something that policymakers have to take in serious consideration. It's not only a matter of wildfire prevention, it's also a matter of financing rural revival and providing multiple ecosystem services. It's not only a matter of short-term solution, but also in a mid or long-term one. Anyways, green belts may function also as safety zones for firefighters. Of course, the challenges are many. We need to educate, inform, help citizens to be prepared, to be safe, to be able to take preventive measures, and of course to avoid panic. And of course, we need as experts and policymakers to address the uncertainties, which is a crucial matter. That is, we need to take into account there are many cases during which fires may spread in parallel. That is, we may have 2 or 3 or 4 large or high intensity fires. And this is the case during which right decisions by the citizens are crucial, because that way citizens help indirectly firefighters saving firefighting resources. Wildfires often sweep through settlements, so there is a clear need to discuss, to try to address the strengths and limitations of the citizen alert systems, which are very helpful, but they have not only strengths but limitations also. There is a clear need to educate and prepare the communities, to help them understand what resilient and vulnerable structure means, what it means to be prepared and unprepared, to help them address weaknesses locally, regionally, or nationally, to offer guidance to people on needed safety improvements, such as to suggest, to make them understand what is the proper way to react in case of fire. For example, to avoid delayed evacuations, which is a major factor leading to accidents many times around the globe. We have experienced cases like those, tragic ones. So people are mostly killed outside. This is something that we need to stress, and something for which we need to discuss thoroughly with citizens and policymakers, that late evacuation is not an option many times. Of course, there are many different characteristics across Europe and around the globe, local attributes play an important role, leading decisions in one or another way. But anyways, depending on these local characteristics, we need to find the best solution in order to keep our people safe and keep open firefighting resources, help support the firefighting mechanism. Sheltering in wildfire resilient homes is an option in countries with resilient homes, of course. So being resilient and prepared is a major issue, because a resilient house is a safe one and it can function as a shelter. Of course, staying is not an option for structures like this one, which is flammable, not resilient, not safe. And of course, the opportunities through lessons learned approaches, which allow synthesis, synergies, and improvements in prevention and suppression. We can try to utilize traditional knowledge with cultural aspects, paying attention to findings derived from scientific research. Regarding recommendations to policymakers, we need, of course, to employ more science, more applied research, because even though sometimes scientific tools have limitations, have weaknesses, they are very useful if we have a robust documentation on what is happening and what we want to achieve. So in that kind of game, Forest Service cannot be absent. We need to try to strengthen the role of Forest Service across Europe, and not only across Europe, because we think that crisis management lack many elements, and we need to have a broader approach, which is natural disasters management, which is natural phenomena management, and this kind of approach includes Forest Service, not only civil protection. This is another discussion we can start and conduct in the near future. There is a clear need to help citizens enhance self-protection. This is a key issue for wildfire management during difficult fire seasons. And we need to take a closer look in what is the use sometimes of technology, if it frees up time for more strategic work or not, what can we do to avoid potential drawbacks so as to be more effective and efficient. Thank you very much for your attention.
Thank you, Miltos. Thank you for a very interesting talk. Thank you also for keeping the time. There is a comment, I would say, from in the chat box regarding public safety power shutdowns at the moment in Sacramento Valley. I don't know whether, Miltos, you would like to make a comment in terms of this topic. I mean, the shutdowns of the power shutdowns when there is intense winds, in order to avoid, for instance, potential ignition sources. Any comments on that?
Like me to comment now or at the end of the presentation?
There are 2 or 3 minutes. If you want, you can comment now. But of course, we're going to have more time in the panel discussion at the end of the presentations. Okay, but since we've lost some time, perhaps it's better to group all questions at the end. And so we would like to thank Miltos again for a very interesting presentation. I would like to welcome Mike and Anthony for the joint talk. Hello. Just once more, keep an eye on time, and the floor is yours.
Excellent. Thank you so much, sir. Yeah, thank you for having the Esri Fire team on the call today. We certainly are looking forward to presenting some resources that are available to you and that you can leverage today to help mitigate and reduce the impacts of the wildland urban interface issue. I am Mike Cox. I am the Director of Fire and EMS for Esri, as you heard from the previous introduction, and I'm joined by Anthony Schultz, our Director of Wildland Fire, who will introduce himself a little bit further in just a moment. But I just want to make a statement about my background is the traditional neighborhood firehouse kind of deployment. So, my agency for 27 years was not primarily responsible for wildland fires. That was, if there was a wildland urban interface incident into a community or city, we had to deal with it, or it was within our jurisdictional boundary. But then Anthony was truly a wildland firefighter. So Anthony, you want to say hello and we'll get into it.
Yeah, hey everybody, good morning and good afternoon out your way, and nice to be here. Thanks for having us. And like Mike said, my background is heavy in fire management operations. I'm a fire guy at heart. So you'll notice that, I think, as we go through our presentation. And so if you have any operational questions, I'd be happy to answer those as well on the US side of things. So take it away, Mike.
Excellent. Thank you so much, Anthony. So one thing I want to make a note of is you'll see our emails there on the slide. Please grab those, and that QR code actually goes to my contact information. But please get our contact information, because we do have resources in your area. We're an international company that supports public safety significantly with some great resources. And it's likely that if you work for a government agency, you probably have access to this technology, everything we're going to discuss in just a few minutes. So again, please, if you don't have our contact information, grab it here. And if you have any additional questions after the webinar, please let us know. But why are we talking about geospatial technologies? Well, because nearly everything we do in public safety has a geospatial component. So every time that fire truck responds to a fire, to a house fire or brush fire or wildland fire, and sets the brake in front of that structure, we're collecting that data point for later analysis. And so that data point has a location component. So it's important for us to be able to look at things in that geospatial context and to be able to collect data in the field, bring together existing data sets like geography, topography, building stock, parcel data, things that really help us understand the impact of these incidents, and bring them together into one visual model that you can then understand the data. You can tell your story and share this data and these data sets to stakeholders, to other agencies. The public can understand the impacts of these incidents. We bring these together in a number of ways, but it's really becoming a mission critical component of our preparedness, mitigation, and response. So what the image you see currently on the screen is what's called the planning P, or the planning process model that we use to manage nearly every incident in most of the world, internationally. Certainly part of our basic incident command structure process within the United States and North America, and again, most of the world. But you'll see there the additional components around the outside are the use of technologies as you move throughout the incident management model. So this model is actually from the FEMA, the National Emergency Management Agency in the United States, their response branch and their urban search and rescue program. So when we see responses to hurricanes, earthquakes, large wildfires like we recently had in New Mexico that deployed FEMA resources, this is the process they're using, and this is the technology they're leveraging to build efficiencies into that response, whether again be a wildfire, earthquake, hurricane, tropical storm. But we're seeing these technologies applied in nearly all types of responses, all hazards. And again, not just the response, but the prevention and mitigation of it. Some great examples of the leveraging of technology can be found in the U.S. Fire Administration in the United States. Just a couple of projects I wanted to point out here. This is a fire fatality and social vulnerability explorer hub. Again, these are technologies that you have access to through your agencies. But this basically gives an overview of the social vulnerabilities, the demographic components of fire fatalities in a very granular look. So it's down to a census tract level, which is a planning zone in the United States. It's relatively small, and it really allows you to explore who is being impacted by these incidents and really what are the characteristics of a typical fatality around these incidents that are occurring in the United States. A new project from the U.S. Fire Administration, and Alex is pretty familiar with this one as well, is the Urban Interface Exposure application. So it's another hub application. But what this does is this takes a look at you can drill down to a single structure anywhere in the country and understand its exposure to the wildland urban interface or the intermix. And much like in our previous presentation, understanding where that ember zone is and what is your really, vulnerability to an active wildland urban interface incident. So you can understand as an agency where to focus resources, where should we, really push for mitigation and prevention activities, and then as a resident or as a community member, you can understand what your exposure is and how you can prepare for those kinds of incidents. We're seeing these geospatial technologies and GIS being used a lot in mitigation and prevention. This is an example from our electrical utility in California, PG&E. And what they're doing is using UAS, drones, and fixed-wing aircraft to collect LiDAR data, remote sensing in the field, LiDAR data of their infrastructure throughout the state of California. And then they can use a machine learning or artificial intelligence machine learning model to identify what areas of their infrastructure have exposure to vegetation or are more likely to cause a wildland urban interface incident. Then they can focus the maintenance resources, the prevention resources, the mitigation resources on the areas that truly need it. So they're not, doing a widespread approach. They can focus on where the problem is and efficiently deploy resources to address the areas of highest risk around their electrical infrastructure. So we're seeing these kind of workflows being done by a lot of critical infrastructure companies in the United States, not just power, but also telecommunications, pipelines, things like that are starting to leverage these kind of technologies to understand the risk to that critical infrastructure and then in turn to the communities that infrastructure is in. Here's a couple of great data sets available from the EU and things like the climate impacts and the trends of climate changes and how it's going to impact this wildland urban interface issue, and certainly another fatality study in the European Union data sets that allow you to understand, again, who is being impacted by these incidents. There are ways to drill down into your data and truly understand who we're serving or who we're trying to protect, or to identify where are my most underserved or at-risk populations. And we can do this through an analysis of demographics. This is just one method you see on the screen. This is our business analyst application that allows you to drill down to a block by block level and pull out information that's important to us as public safety officials. So you can see here with just 3 clicks, I can pull up an infographic that is a public safety focused infographic, at-risk populations. And within that small geographic area, I can tell you how many homes have disabilities, what languages they speak, do they have vehicles for self-evacuation, critical information that's incredibly important, to provide the information to decision makers before and during these events. And then we see localities bringing all this information together into a visual product that's easily usable by other government officials, other stakeholders, and the public. And in this case, this is an ArcGIS hub that was put together by a city in the state of Virginia on the East Coast of the United States that provides all their risk assessment information, their standard of cover and how they respond, and good public information that their stakeholders should understand. So I'm going to turn it over now to Anthony and allow him to pick up on additional mitigation response information around wildland urban interface. Anthony?
Thanks, Mike. So as Mike left off, fuels treatments on the landscape are a pretty big deal here in the United States. We view these treatments as not only maintaining forest health, but actually critical to public safety in the sense that they can start to alter fire behavior well ahead of it, really threatening communities and critical infrastructure. And some of the speakers before have alluded to this. And so how do we keep track of all that data if we're out in the field and we're implementing all these landscape level fuels projects, or even at the community level conducting home hardening projects, community resilience projects? How do we keep track of all that? We're seeing agencies really start to leverage and make a little bit more transparent a lot of their data. And this is just one example of how some of our large land management agencies are doing that, giving, I see a hand up. I'll take questions at the end here. Giving insight into the public, into the United States Forest Service system of record of what kind of projects are they doing? Did it affect the wild and urban interface? What are the actual legal planning documents really providing a next level of transparency into these landscape level treatment projects. And then perhaps more importantly, arguably, is all of this work that we're doing on the landscape, all of the homes that we're protecting, is there any return on investment? Are we putting these projects in the right spot? Are they having the kind of efficacy that we're looking for out of these projects? And that's what you're seeing agencies here in the United States, the questions they're starting to answer. And so the United States Forest Service is looking to start proving return on investment. So for every dollar spent on mitigation projects, they're really being able to start answering back to Congress or some of our decision makers whether or not these fuels treatments were effective and why. As you saw there in the video, the fires stopping along a lot of those mitigation projects. That's a good thing, right? We're proving that these projects have a real and tangible impact on fire behavior and thus public safety. And so where do we house all that information? How do we communicate it to the public? Well, we're seeing agencies and local municipalities, state governments, transition from paper planning documents to digital planning documents. Typically that comes in the form of a community wildfire protection plan. Most states have them. Quite a few municipalities have them across the United States. And so we're bringing all of that geospatial data into what's called an ArcGIS hub, trying to templatize a lot of this workflow so that we're making this available not only for decision makers, but also for the local residents that live within that area, getting a little bit more insight into the fire risk and or projects going on that may affect them. And we're going to transition a little bit into a little bit more of response here with a NIFC org. So in the United States, we have a national structural triage data set. This data set gets updated anytime a structure is threatened and incident management teams on site to start some of this data collection. Every firefighter in the country is eligible for a Field Maps and Survey 123 license, and allows us to build this national structure triage data set. So moving into the future, if this neighborhood becomes threatened again, we already have this entire area structurally triaged, giving a little bit more insight into the suppression actions or even some of the mitigation actions that might be effective in this area. We're also doing that for a lot of our operational data. So what you're seeing here is information. This is live. It's real time. I took this yesterday. Mike mentioned the fires in New Mexico. Over at roughly 1,500 structures destroyed. And this is all of the live operational data that firefighters are in the field collecting, creating a true common operational picture, a shared map, if you will, that decision makers and responders alike can leverage. Then we're getting into a little bit of remote sensing and some of the value that you're seeing here in the United States. We've got camera networks all up and down the state of California. We've got over 1,000 cameras linked directly to CAL FIRE's dispatch intel unit. You see smoke popping up in this video feed on the left-hand side here. We're regularly beating 911 calls. So we heard speakers a little earlier reference early fire detection. This is one of the ways we're starting to get at some of that early fire detection, where these cameras are detecting smoke, relaying that alert to CAL FIRE's intel unit, and then from there they're confirming that yes, we do in fact have a fire. And within 3 minutes of ignition, you can see aerial resources arrive on scene and extinguish that with retardant. We move then to some of our IR mapping, where we will launch those same aircraft outfitted with remote sensing sensors, typically IR, to produce the maps that you're seeing here and that we just went through. And then within that NIFC order, that shared common operating picture. In the interest of time, we'll move on to some of our smoke forecasting air quality. This is emerging as one of it's a passion project of mine, really. And one of the larger issues here in the United States, and it's the issue of smoke and associated air quality, particularly with PM 2.5, or those smaller particulate matter elements that get deep into the lungs. And on the right-hand side here, you're seeing one of the worst air quality smoke days in the United States, and that's from the Canadian wildfires here last year. We're able to monitor the movement of that smoke, and as Mike mentioned, really zero in on a lot of the public health measures that might have to be taken to protect some of the critical infrastructure like hospitals or vulnerable population sets within those areas. And then, of course, evacuation analysis. We heard evacuating at the time of ignition might not be the right move. And there's been a lot of discussion around what's called temporary fire refuge areas, TFRAs, shelters of last resort. And so utilizing GIS, we're able to then go ahead and identify those areas kind of on the fly, and then get those associated impact metrics. How many people are we actually evacuating? How many have access to cars? How many speak English? Do we have to have some sort of interpretive efforts going on to really make this evacuation successful? And then we touched on really briefly here, artificial intelligence and machine learning. Traditionally, artificial intelligence at Esri hasn't really been like a air quote Esri GPT. Although that's coming, you should watch come to our UC here because there's some exciting new technology that way. But really leveraging AI and imagery for damage assessments. So this is what you're looking at here is the imagery and the initial damage assessments from Lahaina, where we were able to leverage satellite imagery post-disaster and classify these buildings as either damaged or undamaged in roughly about 9 hours. That was with writing the model, and so now we're really hovering around about 2 minutes once an agency is able to obtain that imagery. That could be UAS, it could be a satellite image, but once that imagery is obtained, it takes about 2 minutes to run this model with building footprints, and you can have some sort of look at where damage is most heavily centered and where to kind of align those incoming resources for any kind of search and rescue operations or USAR that might be required. So with that, I think I'll end and hand it back over to our moderators. Thank you.
Thank you very much for a really, really interesting presentation, looking at the other side of the Atlantic Ocean and what is happening there, quite impressive. There are a couple of questions, but since we're running a little out of time in terms of the presentations, we'll group all questions together and we'll look at them at the panel discussion later on. Last but certainly not least, I would like to welcome Monica. Her presentation regards enhancing cross-border risk assessment for critical infrastructure. And Monica, the floor is yours.
Good afternoon, many thanks. Let me share my screen. Apparently, I don't have the permission, so I would appreciate if you can share the screen on my behalf. Thanks, many, many thanks. So good afternoon to everybody. Thanks for the invite. I'm Monica Cardarilli and I work at the Joint Research Center, which provides scientific-based support to EU policymaking and is part of the Euro Commission Directorate General. So I'm just, next slide, please. I'm just going through 3 main pillars, so a bit an overview of the main EU policy landscape with a specific focus on the recent critical entities resilience directives, which whose transposition is due by the member states in October. A bit about the risk assessment and needs, the cross-border and cross-sectoral aspects, and how also interdependencies needs to be addressed, also in light of the policy landscape, with some real cases on wildfires, and concluding with an overview of the main GRC supports and next step foreseen. Next step, please. So as let's say the critical infrastructures are getting more and more interconnected to each other's, the EU policy landscape has evolved over time, specifically moving from the concept of critical infrastructure relating mainly to the asset, the system level, to a broader concept of defining critical entities as the system that provides essential services. And this also has evolved in terms of coverage, moving from protection to resilience, more broader concept that includes not only protection, but goes more into broader terms, and is to reflect more on the reality of today's infrastructures and interconnectedness. Next slide, please. So what the directive requires is for the member states and critical entities to assess the risk and also to enhance the resilience measures. And all this assessment includes both natural and man-made risks. Here you can see some examples. It also requires a cross-sectoral and cross-border approach, and also the reference to specific existing risk assessment to avoid duplication of efforts and also to ensure consistencies. And this also includes the different, let's say, aspects that are related to multiple sectors, so the interdependencies, and also the geographical coverage, so how an impact can cascade or can be induced by third countries outside, let's say, the EU boundaries. So focusing mainly on the risk assessment, we are going to see how this is tackled by the directive and how we can really support the implementation. Next slide, please. So when it comes to the risk landscape, we have to consider risk as a dynamic phenomenon. So that can be fast or slow onset phenomenon. And in this dynamic process that sees the geopolitical landscape moving, also climate change affecting the patterns of different hazards and the frequency, we have to approach risk in an evolving manner. So including emerging risk, so new risk, but also existing risk that might have different impacts and different frequencies over time, affecting the way these risks should be handled. So in terms of level, but also in terms of type, as new ones may evolve and emerge over time. And this also comes and affects the different components of risk, from the hazard to the vulnerability and exposure factors. Next slide, please. So what the directive prescribes and how also we see this interconnection across systems is to move from an hazard-driven risk assessment approach to an hazard agnostic approach, where different hazards are treated as a whole. So hazards that can have different, let's say, impacts, or can happen at the same time, or that are interlinked. So there is a time dependencies. And this play a key role in assessing risk in a dynamic way, because hazards can have parallel effects, serious effects. So the impacts should be comprehensive, considering what might happen independently of the type of hazard that we are going through. Next slide, please. So the impact assessment is an important part of risk, and this also should be tackled from different angles, as external impacts that might lead to a critical infrastructure failures, but also what relates to this intrinsic aspects of the infrastructure in terms of aging, lack of maintenance. So considering the impact, not just external factors, but also what can trigger some impacts because of the characteristics of the infrastructures. And this also has different type of impacts to the environment, to the neighborhood, let's say, environments, in terms of services affected, but also potential can propagate geographically, but also can last over time. And this can also delay emergency response, can delay the possibility of reach and support the population in need. Next slide, please. So considering the perspective of looking at impact, it's important to have a critical infrastructure-oriented perspective that looks at the effects affecting the infrastructure, but also what are the implications to the users using the services. So what this means to the different surrounding areas that might lose the power, that might lose specific services and functionalities. And this also counts when defining the disruptive effects that might induce by a loss of functionality, of loss of supply in terms of physical characteristics, concrete aspects, but also how much we can accept the dysfunction, how much we can last without having a service supply. So defining certain acceptability criteria that can take uncertainty, but also turn uncertainty in a way we can deal with them. Next slide, please. So this, to say what, that these aspects are exacerbated when they affect cross-border areas. So when we have to deal with cross-border risk, this is even more complex. Complex because of the geographical nature of a specific hazard and also because of the scale. So there might be cross-border effects. And with the goal to basically emphasize the importance of including the different complexities, the different, let's say, reliances of the services, and also how far a significant effect can last and can, let's say, affect different environments. So what is important is to include high impacts coming especially from low likelihood events in a way that they are interconnected in a systemic approach that include different scales, but also different sectors. Next slide, please. So when we speak about cross-border, we speak especially about the geographic and impact scale, but also the existence of interdependencies that might be physical interdependencies, but also more, let's say, intangible. And this is the most important point of defining exactly the level of the interdependencies, because they might exist at local level, but also at international level. They might exist at different sectorial level, but also a scalar level. And this includes different types of dependencies that are a part of the system, so within the sector, across the sectors, and also in the way that are one way or bidirectional dependencies. So because as we experiment today, there is this lack of understanding of what depends on what and what relies on what. So having a more, let's say, granular understanding of what are the potential impacts that go beyond specific sectors affecting other services is an important point of understanding what are potential links, then potential impacts and risks. Next slide, please. So here are some case studies just to showcase you how impacts can have different perspectives. So we can have impacts that result from risk generated somewhere else. So we can have something that happens in one place, but with, let's say, an initiative, a triggering event that has happened somewhere else. We have also impacts that spill over. So something that happens here might have some consequences somewhere else, and also parallel impacts, so that occur simultaneously with the potential links, but also with links that are not so evident. So it's important to understand in this, using real cases, whether we are speaking about causes or consequences, what are the differences and what this implies, and also whether something is happening by accidentally, or maybe there is, let's say, an intention to impact something, or also to have some effect somewhere else. Next slide, please. So what are the main challenges? The main challenges are essentially linked to the need to have an holistic approach, an approach that brings different stakeholders on the same ground with the same wording, with the same understanding, considering the different barriers that might come from languages to system acquisitions. Also to compare results, because especially when we are speaking about the border, we have different understanding, but also different criteria for assessing what is the most important aspects, and also to compare results, because we can speak about the same hazard, but maybe we have prioritized things differently with different sets of indicators. So it's important to ensure comparability of results, and also who does what when. So who is the main person responsible, and also how this affects the different competent authorities that have to intervene, and prioritize in a way that there is a shared consensus among stakeholders that might have different objectives, but they need to have a common, let's say, background. Next slide, please. So the recommendation exactly trying to turn the challenges into something that can be tangible, something that includes an assessment and work that fit for the purpose, so that involves different expertise, different frameworks to work together, and to also include aspects that are not just direct impact, but they go beyond what might happen if. So in terms of cascades, in terms of compound risk, in terms of interdependencies. And this to ensure that we provide evidence that serves for the next steps from risk assessment. So in terms of risk management and resilience enhancement measures. Next slide, please. So an overview about the main GRC supports. It's quite broad. It starts from specific tools that supports data collection from different past events and statistics. It also provides mapping support in terms of the different projections and viewer solutions, metrics, so in terms of indicators and potential comparability, products that come from publication, but also analysis and forensic analysis, and also training and exercises in terms of building synergies and developing common understandings. Next, please. So what is in front of us? So with the aim of supporting implementation of the directive, we are specifically looking at creating a guidelines material and template that may be used by different member states to develop their risk assessment, but also the way they have to implement the directive. So we have a common ground and also something that can facilitate exactly communication, information sharing, and also reduce the fragmentation and diversity of results. And this also with the aim, with the support of an expert pool. So we are trying to develop a pool of experts, which will be called European Network for Critical Entities Resilience. Next slide. Next, please. Whose goal is exactly to reshape and to take stock of what has been developed by the previous network of experts called ENSIP, broadening in scope, so moving from the protection definition to the resilience concept, and also going to the different sectors that the new directive has brought, starting from the food sectors, the banking sectors, the public administration sector. So trying to be as more comprehensive as possible, and also trying to break down silos, so to create synergies across sectors, and also to develop some initiatives that might foster cooperation. Next slide, please. So here you can find our main channels where you can subscribe, follow, and get to know more on the latest initiatives and events and new policy updates that we are supporting with the help of other colleagues. And thank you very much for your attention, and I'm at disposal for any further questions. Thank you.
Thank you, Monica. Thank you very much for keeping the time as well, and for the very interesting presentation. So now that all 4 presentations have been presented, there is time for a panel discussion open to the audience. Please use the chat box to write your questions to the presenters. We have already some questions, so I would suggest to start discussing them, and then perhaps we have some more. So let me go on the top of the chat box. I see that Alex is already active there and has provided some responses to the questions. There's a question for Mike and Anthony from Edward. How the mentioned exposure of homeowner is calculated? At least in the EU, there is not a standardized methodology, even with legal implications, to do so. So the question focuses on the way that the exposure of a homeowner is calculated.
So the
elaborate, please. Yeah, thank you.
Yeah, absolutely. Yeah, the United States Fire Administration project currently determines the WUI and then the ember zone based on topography, geography, some basic fuel loading or land cover. Knowing that there are many variables that are involved in that kind of analysis. So this is a very basic look at, you know, what is the exposure. So it's not a true risk analysis. It's looking at some basic information that you can change. So weather might change your ember zone, right? Fuel load might change your ember zone. Certainly topography and geography could change your ember zone. the land cover. So that it's a very basic methodology based on, again, those things: fuel load, geography, those kind of things. Anthony, anything else you can think of? Oh, I'm sorry, Alex, cut you right off.
Yeah, I think it's a really good question. It's I'm not going to say it's Pandora's box, but it is a real big, it's a loaded question. It's a great question because the snapshot that Mike and Anthony presented with from USFA is really just that. It's an initial snapshot. These events are very dynamic, and unlike all the other disasters, all of them, without exception, these are disasters that are self-propagating. Because the energy that is involved in the disaster comes from the asset we're trying to protect, right? If a hurricane hits land, the hurricane doesn't get stronger, it gets weaker. Here, if we have a fire that hits a community, if the community is not well prepared, all that community becomes fuel, which then further accentuates the energy release of the disaster and enables the disaster to self-propagate. What this means is, in the context of this exposure, is the snapshot that Mike and Anthony presented, that USFA has put together, is really just an initial estimate. Once fire gets in the community, all bets are off, because once your neighboring house starts catching on fire, the exposure you're going to get is going to be completely different than if that house hadn't caught on fire. So we have to be very mindful when we talk about these disasters, that there is a temporal component at a very fine spatial resolution that really drives what happens. And when I talk about fine resolution, the exposures in these disasters really change in a spatial scale of under 5 meters. You can have very significant exposures in one location, and you literally move a few meters away and the exposure goes down by 1 or 2 orders of magnitude. So that's the challenge, that we are spanning and talking about many different scales. And I think this is a really good segue to start our discussion for infrastructure, because one of the big challenges is that we have all these nested scales that drive a lot of the exposures, which then impact the behavior of the infrastructure. So great question. A lot goes into that, and I put in the chat a quick plug. At least we have our hazard mitigation methodology to help people understand the relationship between exposure and structure hardening, which is absolutely essential. Dionisi, if it's okay with you, I have a few comments / questions for our great participants.
I think there is also another question, since we have Mark and Anthony right now, regarding the fire in New Mexico. And more specifically, the question is how it became so huge. Wasn't it detected by camera at its beginning? So, I mean,
I can
Wind,
elaborate.
fuels, topography.
people are wondering. Yeah.
I can elaborate on that. I put some comments in the chat, but I think it's a good segue again to some of the following discussion. I'm going to provide some statistics for the US, and Mike can and Anthony can also pitch in. But in the US, over 95% of the wildland ignitions are contained annually. By some statistics, 97, 98% of it. So we have a really good track record. But that doesn't mean that everyone is containable. That's the key that I want to stress. So just having the information, knowing where the ignition occurred, doesn't mean that by extension that fire can be contained. Fuel, topography, local weather, available resources, accessibility, all come together to create this, what we call the perfect storms, situations where we just cannot get to it fast enough and hard enough, and then it takes off. And when it does that, if the weather cooperates in a negative way, we can end up with this dramatic event that can cost lives and destroy entire communities. So there is a temporal component in addition to the spatial component to this, if that makes sense to the group here.
I don't know whether Mike or Anthony have any further comments on this New Mexico fire.
No, I think Alex did a really good job summing that up. The thing I will add, well, Alex, we have 98% success rate in Wyoming. No,
I'm trying to be cautious, you know.
Yeah, well, and it's kind of a victim of our own success, right? People will say, oh, well, there wasn't enough responding resources. We need more initial attack. We need more airplanes. But exactly to Alex's point, that's not always the solution. At some point, it becomes we don't rag on NOAA here in the United States for not stopping a hurricane, and at some point, it crosses that line with fire where things just align at that perfect scale from the drought indices in January, February, all the way through that initial firing. And so, weather fuels topography.
Let me before we go on, let me flip this around because I think there is value in exploring Anthony's statement a little bit more. This is the only disaster, really, where we have control of the energy release, right? I think this is absolutely essential for people to understand. And what does this mean? We, societally, cannot stop a hurricane. We cannot stop an earthquake. These events are happening because the energy comes from outside of our built environment. With respect to wildland urban interface fires, we have 100% control of the fuel. So think of it this way. When Anthony said 98% of the fires are contained, think a generation or two from now, we could end up in a situation where we have a wildfire, it takes off, it's not containable initially, it hits a community, and it becomes a non-event. The community is designed to take the hit without losses, and the fire peters out, and we have no more event. We cannot do that without the disasters, but we have the ability to do this here. So, yes, we're in a bad situation, but there's an opportunity looking ahead to completely rewrite how we think about this disaster and make communities stand alone, fully robust, not resilient in the context of recovery, prevent the losses in the first place. So when those wildland hits come in, those exposures, they just peter out. And then we don't have any losses, whether it is fatalities or structures.
Yeah, I see also another question or comment from Mike and Alex from Edward. There is a big challenge regarding the unprecedented extreme events which may change the known rules. So we keep seeing extreme wildfires more often. So what, in your view, is the possible changes to the rules of addressing such events? Yeah,
I can start on this, and then Mike and Anthony can follow up. But again, looking at this, when I say we, big picture, we have a serious challenge ahead of us societally across the globe, not in the US only, because we're seeing, as Monica mentioned, this transitions. The risk is not static, and as Dionysius mentioned, and our commenters, we are seeing climate change, where we're building, and many other factors impacting the hazards and, by extension, the risks. But to me, the reason this is very difficult is not because it only impacts new construction. If the issue was new construction only, we could, wave a magic wand, get political support, change the way we build communities going forward, and reduce that hit. But that's only a very small fraction of the problem. The biggest problem, the biggest fraction of the problem, is the existing building stock, which around the world is not designed to not burn from the outside. We have a century of research, of fire protection engineering research, to manage the fire inside buildings, but we don't have robust standards to prevent ignitions from the outside. And the challenge here is that we have to really raise the bar on millions and millions of homes around the world, really. I mean, in the US, and Anthony and Mike can pitch in, depending on where you set the bar, you have tens of millions of structures in the high hazard WUI areas. So all these things need to be retrofitted. So it is a very heavy lift financially and in terms of political will and societal will. But we have to do it. We really have to raise the bar. Otherwise, not only are we going to lose communities, we're going to keep losing lives.
Yeah, we certainly cannot address these mega fires and these large urban conflagrations with response and suppression resources. That's not going to fix the problem. It's much like Alex is speaking to. Yeah, it's got to be, it's managing the force of the health, like, with Anthony's focus. It's understanding engineering requirements and code enforcement, code development. How are we building structures? How are we maintaining our current structures? And then, of course, it's education too. It's human behavior. It's things we have to get out in the community.
It's an expensive proposition.
100%.
It's not cheap. This is not something that a homeowner by themselves is going to be able to do with a few euros or a few dollars on a weekend.
Right.
The structures are very weak. The codes are very weak. And I'm going to link to what Mike said. Initially, if you look at historically, the codes were not designed in the US to make the home stand alone. They were designed to work with this concept of defensible space to allow first responders to go and help save your home. When you have a community of 20,000 structures that is impacted at the same time, we don't have 40,000 engines to defend every single home. So now we're looking at a complete paradigm shift. We need to move away from this very ignitable structures with defensible space to fully standalone homes. And to do that, we need to raise the bar in codes and standards dramatically. So if you look at our hazard mitigation methodology, which is a very comprehensive performance-based approach to hardening the existing building stock, and you look at what we have in codes and standards in the US, we are seeing a gap of nominally 75%. 50 to 75% of the weaknesses that are out there, out of all the weaknesses that are out there, the code addresses only 25% nominally. In some cases, maybe up to 50. So it's not that we're like 90 or 95% there and we just need to make a couple of tweaks in the codes. In most cases, the codes are completely inadequate to protect against these types of exposures. So it's a huge lift, which is going to be a very significant impact, a financial impact across communities. And we need to look at this nationally of where all these billions and billions of dollars are going to come from to make these communities resilient.
Thank you. Just a comment. I see Joseph I think has a hand raised. Since there's not an opportunity to open the microphone, please ask all your questions in the chat box and we can see them there. So I would also like to ask all presenters to turn on their cameras to have a more open discussion. I mean, sometimes, questions are addressed to someone, but the other presenters can pitch in also. So, yes, thank you. So there is also a question about what are the barriers that limit our opportunity to mitigate and adapt to wildfire incidents, and how likely are we to overcome such barriers? I mean, if someone wants to pitch in, please do.
I can start on this and point to some of our presenters to make some of the connections here. So we heard some really outstanding presentations. I mean, all of them were inspirational, I will say, and extremely educational. I have comments for all four. So just to stimulate the discussion, I'm going to go sequentially. If it's okay with everyone. To me, Emilia, your presentation really resonated in terms of the interconnectivity and connectedness in the space of infrastructure, because we see this in the real world from our reconstructions. this not only impacts recovery, but can also impact the response. And I wanted to, in terms of barriers, I want to ask you your thoughts on how to address the interconnectedness of systems in planning for these disasters. As an example, specifically the linking between power and water, which we see is so critical.
Yeah, not only from all the different critical infrastructure as the complexity of threats or hazard, we can see that we have all different type of cascading effects, and it's very, very difficult to be prepared, but we have to. So from our point of view, it could be useful also to provide resources on how past incidents have been managed in order to understand how to be more prepared. So in our mind, as a EU-CIP, we are in mind to provide also white papers or validated reports regarding the cascading effects, the interrelation among the critical infrastructure in order to support the next all the stakeholder for happening of this type of interconnection or cascading effects.
Great, thank you, Emilia. This is exactly the type of information that I think is going to be very useful to decision makers and the public. To follow up on this train of thought, Monica, I had also a comment on your talk. I think it was extremely comprehensive. What you have presented was very, very powerful. And one of the interdependency notions that really resonated with me was the idea that, you know, when you look at infrastructure, you look at it before the incident, during the incident, and after the incident. That the risks are not static. They are dynamic. They can change in space, but also they can change in time. And one of the things that I wanted to ask you to talk a little bit about is specifically the road infrastructure, because a lot of people typically think of infrastructure in the context of power grid, water grid, communication. But the road grid is really a very important part of the story, specifically, as Miltiadis mentioned, with respect to evacuation. So we can have a road grid that is not destroyed, but is impassable during critical parts of the event because of the exposures. So any thoughts on how this can be integrated into your methodology?
Yeah, thank you very much. That's a very interesting question, because here we can see road infrastructures as being an infrastructure itself in terms of ensuring the services that it provides, but also in terms of users. So because this is one of the key aspects of ensuring the functionality of the service, but also the use of the service by the users. So in this is the important aspect is to keep this dual perspective of considering an infrastructure from, let's say, the asset, the system level that it has to keep working, but also how this can be, let's say, restored. There can be emergency responders, there can be firefighters, also in terms of how this another can affect the road infrastructures. It might be because there is something burning, so there is smoke, or maybe because it leads to a physical disruption. So the road is not usable because it's destroyed. So the damage, the failure is also another aspect of ensuring the functionality and the usability.
This is great. This is absolutely great. And I think this is a great segue to jump right into Miltiadis, because I see a really important connection when we talk about infrastructure. Let me give a little bit of background. In the US, We don't have any standards right now for fire shelters or temporary fire refuge areas. There's a national effort to create, to rewrite the evacuation story to make sure that, as Miltiadis said, we don't pull the trigger when people cannot get out. So I think there are great opportunities to leverage temporary fire refuge areas as we go forward, and ultimately fire shelters when we have the scientific and technical know-how and standards to build them accordingly. The comment I want to share with Miltiadis and get some feedback, I think the landscape scale considerations of agriculture are extremely important that you highlighted. And I would like to get your thoughts on how we can link this to evacuation to make sure that we can use such a tool to keep the arteries clean, to reduce the exposures to the key evacuation arteries. Miltiadis, you're muted.
Thank you very much, Alexander. Of course, yes, considering that no single tool, no single measure can be considered as panacea, no single tool can cure all. On the other hand, we could argue that agroforestry systems can be used as, let me say, leverage point. They can be used for reducing risk or fire damage. They can be used for protecting infrastructure and settlements. And on the other hand, we can connect fuel management in that context, fuel management with fire prevention, which will allow people to stay and defend their houses. It's a tricky matter. It's not an easy task to find out who is able or capable of defending his or her property or not. But I think that we should focus in the near future to what we could do in order to increase our social resilience, not only our fire resilience. So yes, agroforestry might be a great tool to help us achieve resilience and sustainability in the framework of climate crisis management.
Thank you, Miltiadis. I'll get back to a comment in a sec, but since we only have Mike and Anthony for a couple of minutes, Mike, can you briefly highlight how critical is a definition, how critical are definitions in the context of creating data layers? As an example, how far do you draw the line in the WUI from the wildlands, and how this can impact your data and the analysis?
Yeah, I mean, data schemas and agreed upon, data, or even just the basic measures of the risk or of the hazard rather,
right,
has to be standardized, has to be a common approach, right? A common language as we deal with these significant issues, because all stakeholders have to be playing off the same sheet of music, right? We have to be able to have the same understanding of impacts, understanding of how our communities are or are not resilient for these specific hazards. Anthony, I don't know if you want to add to that.
No, I think that's right on. And we've got some infrastructure here in the United States that allows that to occur. There's several different avenues, one of those being the National Wildfire Coordinating Group. We actually have a National Data Management Committee with a boatload of subcommittees that address each one of these different issues that really allow us as a nation to kind of coalesce around some of these data schemas and definitions. To your point, Alex, being able to define wild and urban interface shouldn't be that big of a deal, but in fact, it actually kind of is. It has a lot of policy implications. And so being intentional with how we lay out those data schemas and define these things is pretty paramount to the success of any of those efforts.
Yeah, thank you both. And thank you for participating. I know you have to leave here shortly. I just want to elaborate a little bit on the definitions and use some context and go back to Miltiadis and to the rest of our esteemed presenters for some maybe closing thoughts on exposures and the links to infrastructure. So let me elaborate just a little bit. So the reason I brought this up with Mike and Anthony is because in the US, the definition of the WUI, the federal definition of the wildland urban interface, has significant impact with respect to funds on location for hardening infrastructure, hardening buildings, codes and standards, et cetera, et cetera, et cetera. But what I want to stress is fire doesn't care about ownership, right? And we need to be very mindful about how we set up those definitions, because we've seen situations, and I'm going to give a specific example, the Tubbs fire in Santa Rosa in California, where the fire went in for a couple of kilometers into the community beyond the edge of the wildland urban interface definition. The fire didn't care that we had created this arbitrary barrier on the map. So I want us to be very mindful how we set up the data sets, because we can very artificially create context that can yield very dangerous deductions, or can yield very misleading information. So the definitions are extremely important. And because this problem, the wildland urban interface fire problem, and by extension the infrastructure issues associated with it span so many scales, it is important for all of us to be on the same page and make sure that the definitions that we use carry through and are articulated very clearly. So that's kind of the preamble to my comment, and that I'll turn over to our esteemed presenters. One of the challenges that we're seeing in the wildland urban interface for the built environment and infrastructure is because fire doesn't care about ownership, the exposures, and by that I mean fire and embers, can come from an adjacent piece of land with an adjacent ownership. So let me give you two examples. You can have a building, a residence, and then the exposure to that can come from your neighboring residence, from your neighbor's house. So your neighbor's house catches on fire, you have no control over that fuel, and that house catches your house on fire. So when we try to manage that risk, we think in terms of managing exposure and hardening the infrastructure of the buildings. Sometimes we don't have control over the exposure. So this applies not only to residences, but also applies to infrastructure. So going back to what Miltiadis said, one of our big concerns in the US with shelter in place is that we don't have a yardstick right now. There are no standards to say what is defensible, what exposures are defensible, under what conditions, with what tools and what training. So it can be very dangerous to let people stay in these environments and get exposed. And we know this from history, going back to the Black Saturday fire in Australia, where people stayed and burned because there was no yardstick to say what is defensible. So I think that's a very, very important message. But I want to turn it over to the infrastructure discussion here specifically, and highlight that when we look at hardening infrastructure, we have to really be thinking about where this exposure comes from on the fire side, because we may not have control over it. And not having control doesn't mean we should ignore it. It just means we have to address it by hardening or finding a way to control it. Because if you have a cell phone tower and the edge of the property that the cell phone tower is on doesn't give you enough of a buffer, then the exposures will come from the outside and may overwhelm the infrastructure. So going back to what Monica mentioned and to what Emilia mentioned, I think understanding the true hazards that are connected to the infrastructure are absolutely essential to help us make sure we harden them very mindfully, both for fire and embers. It's a very challenging task, but I want to, if there's one message I can convey to the whole, to our esteemed presenters and to our audience, is look at exposure. Don't look at the parcel boundary, because fire doesn't care about the parcel boundary. So we have to really be thinking in terms of flames, radiation, convection, not we have this piece of land we're going to protect and completely ignore what's going to come from the outside. So those are my kind of final thoughts, and I'm going to turn over. Let's start with Miltiadis, and then we'll go around to Monica and Emilia with their final comments on this thought.
Yes, there's no objection, Alexander. Yes, I fully agree with what you mentioned. I think that we are dealing with complex, spatially and temporally speaking, very complex issues. So yes, there is no single advice that we could give so as to keep our people safe. Yes, it is changes. It changes dynamically. It's a dynamic process. It's a phenomenon that changes in space and time. And what we need, that's why we need people to be educated. That's why to invest, I think my view is that we need to invest in the near future, in the next months and years, to people's education, so as for them to be able to understand the meaning of preparation, and of course, be able to combine all whatever you just analyzed to all of us so clearly and thoroughly, to be able to combine all this kind of knowledge and be able to make decisions. Because what I think, and this is the last phrase of my statement, and thank you very much for this opportunity. What I think is that every firefighting mechanism has its threshold beyond which it breaks. So what we need in the near future is to avoid our firefighting mechanisms to break frequently. And the basis that we need to create so as to avoid this kind of result is to help people understand if they need to leave early so as to protect themselves, how important it is to cooperate with agencies and authorities, how important it is to be able to understand the message that comes from the alert systems, and if needed, if they don't have the time to evacuate early and safe, to be able to protect themselves, seeking for shelters, seeking for fire resilient structures.
Thank you, Miltiadis. Monica, your thoughts?
Yeah, I think that what would be needed is to define the governance frameworks that are service-oriented and no territorial-oriented. Because if we have the view towards the service that has to be kept functioning, it needs it covers by definition the multi-level, the multi-territorial level. It covers the multi-ownership, so from public and private sectors. It involves the different affected users, the population. So including having the service-oriented perspective ensures that this multi-engagement is enforced, and this allows to identify the different responsibilities and to develop effective agreements, protocols in case something happens, but having the service as the main target.
This is great, great input, Monica. This is fantastic. Thank you so much. And Emilia, to you for the last word.
Yeah, I agree with all the answer given by the other for sure. And I suppose that as you can see, the exposure cannot be controlled, but we have the power to apply strategies and measures that can be implemented also to manage and mitigate the risk. So our goal is to reduce vulnerability, enhance resilience, and have a quick recovery. So with a good risk assessment and management, but also resilience building, we can try to mitigate and to have also a good preparedness and response planning for sure.
This is great. Thank you all for the fantastic presentations. I'm going to turn it over to Nikos and Yorgos. Dionys, unless you have any other thoughts, I think this was a fantastic series of presentations and great discussion. Thank you so much.
Yeah, Alex, I totally agree. Very, very interesting presentations, very interesting discussion as well. We have some more comments and questions coming up to the chat, but I guess this can be addressed at a later stage. So let's hand it over to George and Nick for some final words.
Okay, Nikos has just faced another technical problem. Unbelievable today. Okay. First of all, we would like to thank you all for being here, you know, and it's a bit late for you in the USA. It's a bit early. Yeah. We would also like to thank, let's say, Sebastian is here on behalf of the coordinator of the Firelogue from Fraunhofer. We would like to, yes, please. Okay, thank you for opening your camera. We would like, let's say, to thank you all. Nikos indeed has a big problem with Teams. It collapsed